Okay, we're going to start looking at filling in the rest of our unit circle. So what we're going to do in order to do that is use these special right triangles. You might remember these from last year, but there's a couple special right triangles that have some certain ratios amongst their sides that we're going to use to set up those point values of the angles that we're concerned with. So first we're going to deal with the 30, 60, 90 triangle. In the 30, 60, 90, whatever you have for this side, so the short side, if you take it and multiply it by the square root of 3, okay, that'll be the length of the long leg. And if you take it and double it, that will be the length of the hypotenuse. Well, since on our unit circle down here, we're going to be looking for this right triangle. Okay, so our right angle is going to be here. And since it's a unit circle, we want our radius to be 1. So that means that my 2x equals 1, which means x equals a half. Okay, so this would be my x, so that's going to be a half. And this would be half times square root of 3, which we're just going to call square root of 3 over 2. Okay, and we're going to use these relationships to figure out what these points are. Okay, in fact, I can see right now that this point is over square root of 3 over 2, and it's up a half. Okay, so that's how we're going to use the 30, 60, 90. So let's just change it so that we've got the right ones. Actually, we'll change it down later. The other one we're going to have is when you have an isosceles right triangle. And what you get here is whatever this is the same as this because it's isosceles. And from the Pythagorean theorem, I could get that x squared plus x squared is 2x squared, and I square root it to get the hypotenuse. And so what I get is x times the square root of 2. Now once again, we want this to be 1 because this is going to be our hypotenuse. Okay, so if I solve this, I'm going to divide by square root of 2. So I get x equals 1 over the square root of 2. Now remember, we're not allowed to have radicals on the denominator. So I'm going to rationalize, which gives me a square root of 2 over 2. So that's what x is here. So we're going to use that to our advantage. So this is 1. This is square root of 2 over 2. This is also square root of 2 over 2. Okay, and again, this was 1. This is a half. This is square root of 3 over 2. So what we're going to do is we're going to just look at where we can put these triangles. So let's see. This is my 60-degree angle. This is my 30. So I'm just going to move this around up here and see where else we can put it to get points here. Oops. So I've already got that one. So let's just erase this for now. So I can put okay, I can put this, let's see, and I always want my hypotenuse to be my radius, so I'm going to flip this around here. Spin it up. So I've got this. So if I put that here, so I'm a little off, but now this is my 60-degree angle, which we know is this line here. So if you remember, this was my 1/2. So now my x movement, okay, my x value of this point, okay, because this point is over half. And now my height, my y value is the square root of 3 over 2. Okay, we can bring the 45, 45, 90 up here. Okay, and that's going to go here. And remember, this was the square root of 2 over 2. This is also the square root of 2 over 2. So that means this point is over square root of 2 over 2, and it's up square root of 2 over 2. Okay, of course this point here, I've gone over just a radius, because I haven't gone up at all, so I've just gone over 1. I haven't gone up at all. This one, my radius is just a straight up radius, so I'm going to have 0 in the x direction and 1 in the y. If I go this way, I'm just a radius this way, so it's negative 1, 0. And here I'm straight down a radius. Okay, these are the only values that you have to know in order to fill in the rest of your circle. Because what you're going to look at is, if you're dealing with one of the 45 or the pi over 4 angles, then you know that it's going to be square root of 2 over 2 away in both directions, over and up. So if I go over here and look, I know that I'm square root of 2 over 2 up and over, but I'm over in the negative direction. So this is going to be negative square root of 2 over 2, and I'm still positive in the y direction. If I move down, I can get this out of here. Okay, if I come down to this next pi over 4 angle, okay, this would be 5 pi over 4. I know I'm still going over square root of 2 over 2 in the negative direction. So negative square root of 2 over 2. And I'm going down square root of 2 over 2, which is negative also. If I go to the last one, now I'm going positive in the x direction, square root of 2 over 2. But I'm still going negative in the y direction. Now to figure out the other ones, you just have to think of it this way. For this first point, my x value is larger than my y value because this is my x. Okay, I'm going over. Okay, I'm going over farther than I'm going up. So the square root of 3 over 2 is bigger than 1/2. So whichever one is bigger, that's going to be the square root of 3 over 2. And whichever one's smaller is 1 over 2. Here's another way to think of it. If you notice, I've got square root of 1 over 2, which is 1/2. I've got square root of 2 over 2. And I've got square root of 3 over 2. Okay, so they go in order. So if I'm looking at the x, this point is closest to my 0 value for x. Okay, it's closest to the y-axis, okay, so which is where x is 0. So as I move over, it's closest, which is the smallest one. This one's a little further away, which is this one. This one's the furthest away, which is the biggest number. Okay, so if you think of it that way, it should be pretty easy to remember all the points on their unit circle. So let's just go through and fill the rest of these in. Okay, if I look just at my x's, I'm going over, not very far, so I'm going to put the small one in here. But I'm going up a lot. Okay, this is taller than these other ones, so this is the biggest value. Okay, and now I need to look for my signs. So I went negative in the x direction. I'm positive in the y direction. Okay, I filled this one in. Okay, it's over a little further. It's up a little bit less. Okay, so bigger than this, less than this. The last one I'm going over the most in the negative direction. I'm going up the least in a positive direction. Okay, so you guys should be able to fill in the rest of these. And from now on, it's up to you to know everything on this unit circle. So you need to know all the points. Okay, you need to know all the degree measurements and all the radian measurements. And we're going to start practicing at the beginning of class every day. So now let's move on. Now that we've got our unit circle, we're going to want to use it in order to start solving some actual trig problems. Okay, theta is the angle that we're using when we look at our unit circle. So whatever angle I'm making starting at 0, okay, these are just different versions of theta. Okay, maybe theta is bringing me all the way around here. That's theta. Now, that angle determines some different values, okay, because it leads me to this point. If I want the sine value, okay, the sine is the y value of the point. The cosine is the x value of the point. And the tangent is the y value divided by the x value. Okay, and these are the three basic ones. And these are their inverses. They're multiplicative inverses. It's not the function inverse, but it's their multiplicative inverse, so which basically means reciprocal. So this is cosecant, this is secant, and this is cotangent. It's easy to remember which one goes along with which, because every reciprocal pair only gets one co. So this is sine, which doesn't have a co in front of it, so it goes with the cosecant, because together they get one co. This is cosine, so it has a co, so it goes with the one that doesn't have a co. This is tangent, it doesn't have a co, so it goes with the cotangent. Okay, so now if I want to find the sine of a certain angle, okay, so let's look at some. Let's say I want the sine of, let's see, this would be 5 pi over 6. So if they say, what's the sine of 5 pi over 6? And we look at the y value, it's 1/2. What's the cosine of 5 pi over 6? It's negative square root of 3 over 2. What's the tangent of 5 pi over 6? I'm going to take the y value and divide it by the x value. So 1/2 divided by negative square root of 3 over 2, which means I'm then multiplying by the reciprocal of this, okay, which is going to cross reduce here and give me negative 1 over the square root of 3, which I have to rationalize. So I get negative square root of 3 over 3. Okay, so I've got some more examples we'll kind of run through. But before I do that, I want to point out which ones are even and which ones are odd, because this is going to help us. Okay, so even functions would be cosine, therefore secant is. Our odd functions are anything that has a sine in it. Okay, and technically, since sine is y, tangent is, you could think of it as the sine divided by the cosine. Cotangent would be cosine divided by sine. So these are odd functions also. Remember, odd means if you put a negative value in, you get the negative of what you would have gotten out of. So let's look at our circle here. And let's look at cosine values and think even or odd. Okay? So cosine is even, which means if I put a negative value in, I'm going to get the same value out as if I had put the regular number in. So let's find a couple negative values. So this is pi over 6. This here is negative pi over 6, if you think of it that way. If I take the cosine of pi over 6, I get square root of 3 over 2. If I take the cosine of negative pi over 6, I get negative, or I still get the same thing. Okay, I still get square root of 3 over 2. If I take the sine of pi over 6, I get 1/2. If I take the sine of the negative of that, I get the negative of what I got out. So that's even and odd functions. So let's just look at some here. Make sure you rationalize. I want the 6 trigonometric values of the given angle. So I want the sine of pi over 3. I want the cosine pi over 3. I want the tangent of pi over 3. And then I'm going to want the cosecant secant, and the cotangent. So the sine of pi over 3, I know that on my unit circle, this is pi over 3, okay? It's up one. It's the third one, which is close in the x direction. Close, so the small number. It's far away in the y direction. So that gives me the basic ones. Now tangent, I'm going to take the y and divide it by the x, which is the same as multiplying by the reciprocal. So I get square root of 3. Now to get the rest of these, I'm just going to reciprocate what I've got. So this would be 2 over the square root of 3, which I rationalize to get 2 square root of 3 over 3. Here I'm going to reciprocate this and get 2. Reciprocate this and get 1 over the square root of 3, which I rationalize. Get square root of 3 over 3. Let's look at negative 3 pi over 4. On my circle, I'm going back 3 pi's over 4. So there's 1 pi over 4, 2 pi's over 4, 3 pi's over 4. So I'm here, which is, since it's over 4, it's halfway. Okay, so it's the middle one. So it's the middle in the negative x direction. It's the middle in the negative y direction. So the sine of negative 3 pi over 4 is negative square root of 2 over 2. Okay, this is also negative square root of 2 over 2. Tangent, since the tangent is going to be this divided by this, I've got something divided by itself, so it's 1. And then I'm just going to reciprocate all these to get the other ones. So the cosecant, I'm going to reciprocate and get negative 2 over the square root of 2. Rationalize. Get negative 2 square root of 2 over 2, which reduces to just negative square root of 2. Secant, I'm going to get the same thing, because I'm going to flip the exact same thing over and get the exact same answer. Cotangent, I'm going to flip 1 and get 1. Right, 17 pi over 6. Okay, I've gone around the circle more than 2 times here, or more than once. So I'm just going to think. There's 12 pi over 6. Okay. 13, 14, 15, 16, 17. So I'm right here, which is far away in the x. So cosine of this is going to be the big one. And it's in the negative direction. I'm close in the y direction. So I get the small one and it's positive. Tangent, I'm going to take the y, multiply it by the reciprocal, because it's y divided by x. So I'm going to take this, divide it by this, which is the same as multiplying by the reciprocal. Cross reduce, and that's negative. Separate this negative out. So I'm going to get negative 1 over square root of 3, rationalize that. So I get negative square root of 3 over 3. Reciprocate these to get the other 3. So that'll be 2. This would be 2 over the square root of 3, and that's negative. Rationalize. That's negative. If I reciprocate this, it's easier to just go back to what I started with and just say that it's negative square root of 3. Those are the 6 trig values. Okay, so, eventually you should be able to do it without looking at your unit circle. If you need to reference it a little bit to get started, that's fine because we're still learning, but Eventually you want to have this unit circle memorized so you can just think, okay, this is why I really gave you a lot of problems for that first section, so you get used to counting and counting up by sixths or fourths or thirds and finding where you are on this unit circle. Because now you're going to use that to find points so that you can get these trig values.